we are going to discuss the efficiency of transmission of a communication system or the efficiency of transmission of an information channel. You know, the efficiency of a communication system is the ratio of the output power to the input power. So this ratio defines the efficiency of a system. The ratio of the output power to the input power defines the efficiency of a transmission system. We consider a communication link which is made of fiber as shown in the figure. The input power is P1 watt. The output power is P2 watts. As the signal travels along this fiber, the energy of the signal or the power of the signal will decrease, and this phenomena is known as attenuation. So P1 is the input power and P2 is the output power, and definitely P2 will be less than P1 because of the attenuation due to the attenuation process. So P2 will be less than P1. We want to calculate the efficiency of this system, the transmission efficiency of this particular system. So the efficiency of transmission of this communication link will be equal to P2 divided by P1. We divide the output power by the input power, and this ratio will give you the efficiency of transmission of this system. Usually we calculate the transmission efficiency in decibel, that is in dB. So if we want to calculate the decibel value of this efficiency, the decibel value, the dB value of this efficiency will be equal to 10 log of P2 by P1, which is given in equation number 2. So we can calculate the transmission efficiency of this system in decibel with the help of equation number 2. You see, in this particular case, P2 is the output power, P1 is the input power. The system is a lossy system. The losses will take place in this communication link. So as P2 is less than P1, the decibel value of the efficiency of transmission will be negative, and whenever the decibel, the dB value of the efficiency of transmission is a negative, basically it represents a lossy system. If P2 is greater than P1, then the decibel value of this efficiency will be positive. And this positive value represents the gain of the system, right? Now we go back to equation number 2. Let us consider equation number 2 in this particular slide. And what we do, we divide both sides of equation number 2 by 10. If we divide both sides of equation number 2 by 10, we will get to see the second last equation of this slide, which is log of this ratio, that is P2 by P1, and that will be equal to dB divided by 10. So what we do, we take anti-log of both sides of the second last equation, right? So this will give you this efficiency, this ratio P2 by P1. In equation number 3, this P1 is not visible, so on the left hand side, this is P2 by P1. So P2 by P1 will be equal to 10 raised to power dB by 10. So we can calculate this ratio with the help of equation number 3 as well, if the decibel value of the efficiency is known. Okay. Now we consider P2 in milliwatts. Let's say P2, the output power of a system is P2 milliwatt. And we take P1 as a reference, and the reference value of P1 is 1 milliwatt. So if P1 is 1 milliwatt, then we calculate the decibel value of these two powers with respect to milliwatt. And this value will be represented by dBm. So the dBm value of this ratio P2 by P1 will be equal to 10 log of P2 divided by P1. So as P1 is 1, okay, so we don't put the value of, you see, we don't represent P1 over here, we don't represent 1 over here. So if we put the value of P1 over here, the dBm value of this P2 will be equal to 10 log of P2, and sorry, this is in equation number 4, this is log to the base 10, this is not log to the base 2. So the dBm value of P2, can be calculated with the help of equation number 4, right? Now we consider another case. Let's say the output power is in microwatt. Let P2 is P2 microwatt. And we want to calculate the dB value of this power with respect to 1 microwatt or with reference to 1 microwatt. So definitely, if you guys want to calculate the decibel value of P2 with reference to 1 microwatt, so you guys will have to take 1 microwatt value of P1. So let P2 is equal to P2 microwatt and P1 is equal to 1 microwatt. So the decibel value, we calculate the ratio first, P2 by P1, and then we calculate the decibel value of this ratio. So the decibel value of this ratio with respect to 1 microwatt will be equal to 10 log of P2 by P1. And we put the value of P1 in the second last equation of this slide, which is basically equal to 1. So if we put the value of P1 in the second last equation of this particular slide, then the decibel value of P2 with reference to 1 microwatt, this is dB micro, will be equal to 10 log of P2. So this is how we calculate the dBm value of a power and the dB macro value of a power. We go to a cascaded system now. We are going to calculate the efficiency of transmission of a cascaded system. So consider the diagram of this cascaded system. There are 3 elements in this cascaded system: element number 1, element number 2, and element number 3. Let's say the element, let's say the input power of the first element is P1, and the output power of element number 1 is P2. Then the output power of element number 2 is P3, and the input power of element number 3 is P3, and the output power of element number 3 is P4. So if we look at this overall cascaded system, the input power of this cascaded system is P1 watt, and the output power of this cascaded system is P4 watt. So the overall efficiency of this cascaded system will be equal to the output power divided by the input power. The output power of the cascaded system is P4, and the input power of this cascaded system is P1, so the efficiency can be calculated with the help of equation number 1. Equation number 1 gives you the transmission efficiency of the cascaded system, of the overall cascaded system. Equation number 1 can be calculated. Equation number 1 can be calculated with the help of equation number 2 as well. So we can calculate this efficiency with the help of equation number 2. So P4 by P1 will be equal to P4 by P3. And what is P4 by P3? P4 by P3 is the efficiency of block number 3. So we have P4 by P3 multiplied by P3 by P2. And what is P3 by P2? P3 by P2 is the transmission efficiency of block number 2. And then multiplied by P2 by P1. And what is P2 by P1 in equation number 2? P2 by P1 in equation number 2 is the transmission efficiency of block number 1. So the overall transmission efficiency of this cascaded system can be calculated with the help of equation number 2. So this P4 by P1 will be equal to the transmission efficiency of block number 3 multiplied by the transmission efficiency of block number 2 multiplied by the transmission efficiency of block number 1. There is P4 by P1 will be equal to P4 by P3 into P3 by P2 into P2 by P1. So the overall efficiency of this cascaded system can be calculated with the help of equation number 2 as well. Right? Now what we do? We consider equation number 2 and we calculate the decibel value of the overall efficiency of the cascaded system. The overall efficiency of the cascaded system. So let us consider equation number 2 and let us calculate the decibel value of equation number 2. So the decibel value of equation number 2 will be equal to 10 log of P4 by P1. And then we have 10 log of the quantity which is on the right hand side of equation number 2. So you know what is on the right hand side of equation number 2? We have P4 by P3 into P3 by P2 into P2 by P1. Okay, so basically we calculate the log on both sides of equation number 2 and then we multiply it by 10. And the left hand side of the first equation of this slide gives you the overall transmission efficiency of the cascaded system in decibel, which is represented by dB. So the dB value of the transmission efficiency of this cascaded system will be equal to the right hand side. And the right hand side can be written as 10 log of P4 by P3 plus 10 log of P3 by P2 plus 10 log of P2 by P1. And if you focus on the right hand side of the second last equation of this slide, the first term represents the transmission efficiency of block number 1 in decibels. So the first term on the right hand side of the second last equation gives you the transmission efficiency of block number 1 in decibel, which is represented by dB1. The second term on the right hand side of the second last equation gives you the decibel value of the transmission efficiency of the second block, which is represented by dB2. And the third term on the right hand side of the second last equation gives you the decibel value of the transmission efficiency of block 3. So if you guys want to calculate the decibel value of the transmission efficiency of this cascaded system, you guys can do it with the help of equation number 3. So the decibel value of the overall transmission efficiency of this cascaded system will be equal to the decibel value of the transmission efficiency of block number 1 plus the decibel value of the transmission efficiency of block number 2 plus the decibel value of the transmission efficiency of block number 3. Now, let us consider a lossy communication system. The block represents a communication system, and PT, which is the input power of this communication system, is in milliwatt, right? PT is in milliwatt, and PR, which is basically the output power of this communication system, is in milliwatt as well. And if you look in the block, the losses of the system is represented by dBs. So definitely the losses of this particular system, the efficiency of this particular system, the transmission efficiency of this particular system in decibel will be equal to 10 into log of the output power divided by the input power. And the output power is PR while the input power is PT. So the right hand side of the first equation can be written as, so the decibel value of the transmission efficiency of this communication system will be equal to 10 log of PR minus 10 log of PT. As PR is in milliwatt and PT is in milliwatt, so the dBs value of the transmission efficiency of this communication system will be equal to dBm. This is the dBm value of PR. So we represent, you see, the first term by dBmR, and we represent the second term by dBmt. If we rearrange the second last equation, the rearrangement of the second last equation will give you the dBm value of the received power, which will be equal to the dBm value of the transmitted power, the input power, plus the losses of the system. So the dBm value of the output power of this communication system can be calculated with the help of equation number 4. Now, let us do a few numerical examples from the book. You guys have downloaded or you guys have purchased the book. We follow the fiber optic communication systems by Joseph C. Pallas, and we follow the 4th edition of this recommended book. So let us do a few numerical examples from the book of Joseph C. Pallas. Okay, this is example number 1. Example number 1.1. In example number 1, we have been given a cascaded system, right? If you look at this cascaded system, so there are 3 blocks in this cascaded system. Block number 1, the loss of block number 1 is minus 11 dB. The losses in block number 1 are represented by minus 11 dB. Definitely the loss will take place in block number 2 as well, and the loss in block number 2 is minus 6 dB. And the loss of block number 3 of this cascaded system is minus 3 dB. The input power of this cascaded system is P1, right? And the output power of this cascaded system is P2 and P1 is given in this numerical example. P1 is 5 milliwatt, that is 5 into 10 raised to power minus 3 watt. And what we need to calculate in this particular numerical example, we need to calculate the output power, that is P2 of the cascaded system. So let us calculate the total loss of this cascaded system. We are going to calculate the total loss of this cascaded system in dB, in decibels. So the total loss of this cascaded communication system in decibel will be equal to the loss of block number 1, that is minus 11, plus the loss of block number 2, that is minus 6, plus the loss of block number 3, that is minus 3. So the total loss of this cascaded communication system comes out to be minus 20 dB. So minus 20 dB is the total loss. Now P1 is 5 into 10 raised to power minus 3 watt, that is 5 milliwatt. And we want to calculate the output power of this cascaded system. So we use the third last equation of this slide, that is P2 by P1. P2 by P1, we know that P2 by P1 is equal to 10 raised to power minus dB by 10, right? We know the value of dB, we know the value of P1, so we rearrange the third last equation of this slide. If we rearrange the third last equation of this slide, we get the second last equation. So the second last equation gives you the output power, that is P2. And P2 is equal to P1 into 10 raised to power minus dB by 10. So what we do, we put the values on the right hand side of the second last equation. P1 is known, that is 5 into 10 raised to power minus 3. dB is known, that is minus 20 dB. So if we put the values on the right hand side of the second last equation, we obtain the output power of this cascaded system in milliwatts, and the numerical value of this output power is 0.05 milliwatt. So this is how we do example number 1.1. Let us go to example number 1.2. In example number 1.2, we have been given a communication system. And the loss of, the loss of this communication system is given in decibel, which is minus 23 dB, right? We want to calculate the transmission efficiency of this communication system, that is P2 by P1. We know that P2 is the output power of the communication system and P1 is the input power of the communication system. So we want to calculate this ratio, and we know that this ratio gives you the transmission efficiency of the communication system. It gives you the efficiency of transmission, right? So for P2 by P1, if you look at the statement of example number 1.2, example number 1.2 says that a communication system has minus 23 dB of loss. Compute its efficiency, all right? So we will calculate, you see, this efficiency with the help of this equation number 1.1. If you look at the solution says that when equation 1.1 is solved for the power ratio, we obtain this equation, right? So anyhow, let us calculate P2 by P1. We know that we calculate P2 by P1 and P2 by P1 will be equal to 10 raised to power dB by 10. And the dB value of this system is known. What is the dB value of this system? The dB value of this system is minus 23. So we put this value on the right hand side of the first equation of this slide. Just put the value of dB in the first equation of this slide, and the numerical value of dB is 23. So 23 divided by 10 will give you that dB value of the dB value is minus 23. So minus 23 divided by 10 will give you minus 2.3. So if we put the value on the right hand side of the first equation, we get this ratio, that is P2 by P1. And this ratio, that is P2 by P1, comes out to be 0.005. If we want to calculate the transmission efficiency, the efficiency of transmission of this communication system, we need to multiply this numerical value by 100. If we multiply, excuse me, the numerical value of this ratio by 100, we get 0.5%. So the efficiency of transmission of the communication system in example number 1.2 is 0.5%. We go ahead to example number 3. Example number 1.3. So in example number 1.3, we have been given the input power. The input power of a communication system is 2 milliwatt, and the question says that calculate the decibel value of this power with respect to 1 milliwatt. So basically we need to calculate the dBm value of P1. So the dBm value of this power will be equal to 10 log of P1. So I put the value of P1 in this particular equation, and P1 is 2. So 10 log of 2 will be equal to 3. So the dBm value of this power P1 is 3. This is 3 dBm. This is the dBm value of this power. This is the decibel value of P1 with respect to 1 milliwatt, with reference to 1 milliwatt. So anyhow, we have calculated the dBm value of P1, which comes out to be 3 dBm. Now, if you look at the second loss equation, the total loss of the communication system is given to you guys as well. We have a communication system. The input power is 3 dBm. The total loss of the system is minus 23 dB. And basically we want to calculate the dBm value of the output power, which is represented by dBm-R. Right? So what we want to calculate? We want to calculate the output power of this communication system in dBm. What is given to you guys? The dBm value of the input power, which is equal to 3. The total loss of the system in decibel, that is minus 23. So in order to solve the second part of this numerical question, we use this particular equation. We derived, you see, the first equation of this slide in this particular class. So the dBm value of the output power will be equal to the dBm value of the input power plus the loss of the communication system in decibel. This is the first equation which gives you the dBm value of the output power. So what we do, we put the values on the right hand side of the first equation of this slide. You see, the dBm value of the input power has already been calculated, and that is 3. And the total loss of the system is minus 23. So the dBm value of the output power is minus 20 dBm. This is minus 20. And we know how do we calculate, you see, the dBm value of the output power. We know that the dBm value of the output power will be equal to 10 log of P2. Let's say P2 is the output power. And I play with this equation to calculate P2, right? So you see, log of P2, if we multiply both sides of the equation in line number 3, both sides of the equation in line number 3 by 10, we get log of P2. So log of P2 will be equal to dBm divided by 10. And if we take anti-log of the both sides of the third last equation of the slide, we get P2 will be equal to 10 raised to power dBm by 10. And this P2 will be in milliwatts. So if we put the dBm value of this power on the right hand side of the second last equation, we get 10 raised to power minus 2. That is basically equal to 0.01 milliwatt. So the output power of this communication system will be 0.01 milliwatt. This is how we do the numerical examples with the help of, you see, these equations. Well, later on, I will give you some questions of the exercise as a homework. Thank you so much.